All right, so here's our next section of chapter 9. In section 1, we talked about Pythagorean theorem, so that a squared plus b squared equals c squared, setting up and solving for missing sides, or determining what type of triangle we had. The next section, again, focuses on right triangles, but we work with what we call special right triangles, so ones where we don't necessarily need the Pythagorean theorem to solve for. So in two certain situations, we really don't need the Pythagorean theorem, and we really only need one side of the triangle to find anything else that we need about that particular triangle. And so the special right triangles that we're going to talk about, the first one's going to be a 45, 45, 90. And so we call it a 45, 45, 90 because as you see in the picture, we have two 45-degree angles, and then since it's a right triangle, we have our right angle there as well. So 45, 45, and 90. Now, in this 45, 45, 90, the two things that make this really important are that first, the legs are congruent. So if I can identify, like we talked about in the first section, here's my right angle, I go across the triangle, there's my hypotenuse. If I can identify that hypotenuse, then the legs are the other two pieces. So we've got my leg over here, and we got another leg over here. Okay, so those legs are always congruent. So since I have the two base angles that are identical, 45 and 45, my two legs must be congruent as well. Now, as far as the hypotenuse is concerned, this is the part where it gets a little bit trickier, but if we kind of just focus on the fact that we have the legs congruent, and then the hypotenuse is square root of 2 times as long as each of the legs. So if I take one leg times the square root of 2, I get my hypotenuse. And so that's what this equation right down here is saying. If I know what the leg of the hypotenuse or leg of the triangle is, I can multiply it by the square root of 2, I get my hypotenuse. And so what we're talking about here is like if I have a right triangle and they say it's a 45, 45, 90, then if they give me one side of 2, my other leg has to be 2, my hypotenuse has to be 2 times the square root of 2. So it's just a matter of the legs being identical, and then the hypotenuse, we take the leg times the square root of 2. Now, while we're here, the other thing I would like you to think about is if I had to go the other way. So like if they told me the hypotenuse, how would I come back to a leg? So if I look at this equation right here, it says the hypotenuse is the square root of 2 times the leg. Well, so if I want to undo that and I want to find a leg, then all I'm going to do is take the hypotenuse divided by the square root of 2. So either way I'm working, I'm either going to multiply by square root of 2 or I'm going to divide by square root of 2. And so if we look through some examples here I see my 45, 45, 90. Now I know that either from the fact that the angles are marked 45, 45, or the fact that the two legs, in this case, the legs we're given are exactly the same. Anytime the legs are the same, it's a 45, 45, 90. And so the only piece I'm missing is my hypotenuse. So I'm missing this piece right here. So our theory, or our formula said, whatever the legs are, so in this case 3, we multiply it by the square root of 2, there's my hypotenuse. So all I have to do is take whatever the leg is times the square root of 2, and there's my hypotenuse. In the next example, they actually give us the hypotenuse first. So if I'm looking at my triangle, I go from my right angle across, so here's my hypotenuse. And so now if I want to find a leg, which we know the two legs are identical here, then what I'm going to have to do, so for one leg, I'm going to have to take the hypotenuse 6 and divide by the square root of 2. And then from our first section of chapter 9, we talked about the fact that radicals, those square roots, can't be in the denominator. So we said to take that denominator and multiply it by itself. So I'm going to multiply by the square root of 2. And then I also need to do that on the top, so I'm going to multiply the top by square root of 2. And so then when I combine terms here, 6 times the square root of 2, 6 is outside, 2 is inside. I can't combine them other than just to put them together like this. So I've got 6 square roots of 2 on top. We talked about when we take a radical times itself, so square root of 2 times square root of 2 just cancels the radical and we just get the 2. And so now the only thing that's left is I have 2 numbers on the outside to check. So I've got this 6 and this 2 on the outside. I need to look to see if those reduce. So 6 divided by 2 would be 3. And so one leg would be 3 times the square root of 2. The other leg would also then be 3 square root of 2. So when we have the hypotenuse, we divide by the square root of 2, And then if we have to rationalize, we need to go through that process and then simplify it all down. If we look at this one here, now this one they didn't give me the angle measures, so they don't tell me it's a 45, 45, 90, but the fact that these two sides are marked congruent means it has to be 45, 45, 90. So that means the legs are identical, so that's this leg is 5. And then if I want my hypotenuse, I take the leg times the square root of 2. And so there's my two answers. Now 30, 60, 90 is a little bit trickier because there's a couple of different relationships. So it's not just multiply or divide by square root of 2. And so 30, 60, 90 again is called that because I have a 30, a 60, and a 90. Now in this 30, 60, 90, one of the things that you have to understand is that there's 3 different side lengths in the picture. So we have our hypotenuse, which is the first thing we need to find. So our hypotenuse is always across from the right angle. We have a short side, and our short side is always going to be across from the 30. Smallest angle means smallest side. That's something we talked about in the last chapter. So smallest angle goes to smallest side, and then what we call, so that's called the short leg. So we're going to call it short leg to keep the same terminology. That means the long leg is across from the 60. So when I go across the 60, I get my long leg. And so I have these 3 different lengths that I have to identify. So hypotenuse, short leg, long leg. Every time we get one of these 30, 60, 90s, I should label those pieces. Now, the key, whenever we're working with this type of problem, is to find that short leg. So we always want to identify where that short leg is, because that's going to be how we move from one piece to the next within this triangle. So from the shortest side, the hypotenuse is always twice as long. So if the short side is x, the hypotenuse is always twice that size. And then the long leg is taking the short leg and just times the square root of 3. So as I work my way around the triangle, it's times 2 or times the square root of 3 from that short leg. And so that's what these two formulas down here are saying. To find the hypotenuse, take 2 times the short leg. To find the long leg, take the square root of 3 times the short leg. And then just like on the 45, 45, 90s, if we need to work backwards, all we do is divide. So divide by 2 or divide by square root of 3. So just ask yourself, am I getting bigger or smaller? And then multiply or divide accordingly. So if we look at some examples here, in a picture like this, we have our 30, 60, 90. So here's my short leg because we're across from the 30. We have our long leg down here across from the 60. And then we have our hypotenuse over here across from the 90. So that's the first thing I want to kind of do with these, is just figure out which are the 3 pieces do I have working here. And then from there, it's just applying the formula. So we have the short leg, which is good. That's where we always want to be. The hypotenuse then is double that. So the hypotenuse in this case would be 4. And then the long leg is times the square root of 3. And so we get 2 times the square root of 3. So there's my long leg, there's my hypotenuse. I got my 2 answers. If I look at another example, so again, we're going around the 30, 60, 90. So here's my 90-degree angle. That means this is my hypotenuse. My 30-degree angle, smallest side, means short leg. And 60-degree angle, bigger angle, means long leg. And so we go through and just identify those really quickly. Now in this case, what we have to understand is that I have the hypotenuse to start with. And the key is to get the short leg every time. So if the hypotenuse is twice as big as the short leg, when I come back to the short leg here, I need to divide by 2. And so 10 divided by 2 gives me a short leg of 5. And then I can move to the long leg by multiplying by the square root of 3. And so I get 5 square roots of 3. And then I get my 2 missing sides. In this last example here, with the 30, 60, 90, we have the long leg. So 60 degrees means this is the long leg. 30 degrees goes over to the short leg here. And then the right angle goes across to the hypotenuse. Okay. So now I'm at the long leg. And so that was multiplied by square root of 3 to get here. That means when I want to go back to the short leg, I need to divide by the square root of 3. So what happens here, I'm going to do the work on the left side of the screen here. So I have 4 square root of 3, and I'm going to divide by the square root of 3. Now typically, this would be a problem because I'd have a square root in the bottom of my fraction. But if we look closely here, notice I've got a 3 and a 3 inside the radical. I can cancel this square root of 3 with this square root of 3. And so that leaves me with the short leg of 4. And then from there, I can move to the hypotenuse, which is just doubling it. So the hypotenuse is always twice as big. And so my hypotenuse would be 8. Now, for these special right triangles, they show up in certain instances, in this case, both with squares and equilateral triangles. And so the thing we have to understand here is when I have a square, so I notice it's a square because all 4 sides are congruent, they're all marked, and I have the right angle down in this left corner, which means I have all right angles. And so if we remember for a square, the diagonals cut angles in half, meaning if this was a 90-degree angle on the top here, it's now a 45 on either side. And the same thing down here, it was a right angle because it's a square. Each one is going to be 45 degrees. And so basically what I notice is I have this triangle, so if I look at this top half, is a 45, 45, 90. And so if I want to know how big the sides are, I would take the hypotenuse. So here's my hypotenuse of 12. I'm going to take 12 and divide by the square root of 2. I need to get smaller. We don't like the square root of 2 on the bottom, so we're going to multiply it by itself. So we do that to top and bottom. We get 12 square roots of 2 over 2. And then my 12 and 2 can combine and divide out to be 6 square roots of 2. Now that gives me one leg. So then the other legs also have to be 6 square roots of 2, and that's a square, so it's all the way around. So I can find any of the 4 sides just by dividing by square root of 2. Now, at the same time, with a problem like this, they might ask you for a perimeter. Well, if I want the perimeter of the square, I have to add up all the sides. So I'm going to take 6 square root of 2 plus 6 square root of 2, and so on all the way around. Well, so that means I need to add all the numbers on the outside, so 6 plus 6 plus 6 plus 6, and I would get 24 square roots of 2. So there would be my perimeter if they were to ask that question. Now with the equilateral triangle, we have to go back and think about the fact that in an equilateral, each angle is 60 degrees. But when I drop this altitude, so this right or perpendicular line here, when I drop this altitude in an equilateral, it cuts that top angle in half, meaning each piece would be 30 degrees. Okay, and so what I have here is on either side, so if I look at this triangle on the left side, I have a 30, 60, 90. And so with a 30, 60, 90, I notice that the 6 is the long leg, the bottom piece down here is going to be my short leg, and then my hypotenuse is this longer piece on the outside here. So again, they might ask us for a side length, they might ask us for the perimeter. And so if I'm looking at the altitude as being 6, I need to move to the short leg first by dividing by the square root of 3. And so I have 6 over the square root of 3. We don't like that square root's in the denominator, so we multiply it by itself, and we do that on top and bottom. So I get 6 square roots of 3 over 3. And then the 6 and 3 can divide to become 2, so I get 2 square roots of 3. Now, if I want the length of an entire side of the triangle, then I need to take that short leg of 2 square roots of 3 and double it to get my hypotenuse. And so when I go to double it, I can only multiply on the outside, so my hypotenuse would be 4 square roots of 3. So there's the length of a side of my triangle. And then if I want the perimeter, all 3 sides would have to be that big, so the perimeter, if I take 4 plus 4 plus 4, gives me 12 square roots of 3. Okay, so with that, you should be able to work through the assignments for this section. So you can get those in class or off of Google Classroom. Make sure to ask questions in class or email, or check the answer key as it becomes available to make sure that you have this stuff figured out.